Alright, this is question 1, part A, and it's asking us to show that this is equal to that for any n-dimensional vectors A and B. So, this is a known formula. So then substituting back in, we'd have that A cross B squared is equal to this squared. So squaring everything, we have A, magnitude of A squared, magnitude of B squared, sine squared theta. Sine squared theta is equal to 1 minus cosine squared theta. So we can then write the magnitude of A squared, magnitude of B squared times 1 minus cosine squared theta. And now we can distribute. We'd have the magnitude of A squared times the magnitude of B squared minus the magnitude of A squared times the magnitude of B squared times cosine squared theta. Now we can rewrite this. So this will stay the same. Now we're just going to take out the square. So we'll have magnitude of A times the magnitude of B times cosine theta squared. This is a known formula. So since this is equal to this, we can now write that the magnitude of A squared times the magnitude of B squared minus A dot B squared. And that's exactly what we were solving for. So we have now shown that they are equal. Alright, this is part B of question 1. And saying if A dot B is this and A cross B is that, then find the angle between A and B. So we know that magnitude of A times the magnitude of B cosine of theta is equal to A dot B, which is equal to root 3, as given right here. And we also know that the magnitude of A times the magnitude of B sine theta is equal to A cross B. And so given these, we then have the square root of the first term squared plus the second term squared plus the third term squared. And this becomes the square root of 1 plus 4 plus 4, or the square root of 9, which is equal to 3. And if we divide these, if we do magnitude of A times the magnitude of B sine theta divided by magnitude of A times the magnitude of B cosine theta, we'd get this 3 divided by root 3, and these cancel out, and sine theta over cosine theta is tangent theta. So we have tangent theta equals 3 over root 3, or 3 times root 3 over root 3 times root 3 is 3. And the 3's cancel out, so root 3. So now we have that tangent theta is equal to the square root of 3. So theta is equal to the inverse tangent of root 3. And this is 60 degrees. So theta, the angle between A and B, is 60 degrees. I forgot to say that the magnitude of A times the magnitude of B sine theta is equal to the magnitude of A cross B. That's why we did the square root. Alright, so this is question 2, and it's asking if some points are coplanar, and if not, it's asking us to find the volume of a parallelepiped. And so these points are not coplanar, So since they're not coplanar, we can now proceed to find the volume. And it says it has adjacent edges PQ, PR, and PS. So what we can do is we can find PQ, PR, and PS. Alright, so PQ, it would be 1 minus 1, negative 2 minus 0, and 5 minus 3. So that's 0, negative 2, and positive 2. For PR, it would be 3 minus 1, 1 minus 0, and negative 1 minus 3. So that would be 2, 1, and negative 4. And for PS, it would be 1 minus 1, 2 minus 0, and 3 minus 3. So that's 0, 2, 0. So the formula for finding the volume is as follows. There's actually multiple ways you could go about solving this, but what I'm going to do is I'm going to assign PQ as A, PR as B, and PS as C. So starting with B cross C, I'll find the cross product. So B cross C. So B is PR, which is 2, 1, and negative 4. C is PS, which is 0, 2, and 0. So then we have I, negative J, and positive K. So to find what goes here, we're going to do 1 times 0, which is 0, minus negative 4 times 2, which is negative 8, so minus negative 8. For J, we're going to do 2 times 0, which is 0, minus negative 4 times 0, which is 0. And for K, we're going to do 2 times 2, which is 4, minus 1 times 0, which is 0. So rewriting this, we have that 8I minus 0J plus 4K. And that's just writing it differently. We have this. Now we can find the dot product of A with this new vector. So A dot B cross C would be A, which is PQ, is 0, negative 2, 2. Finding the dot product with 8, 0, and 4. So to do this, we're just going to multiply the first two, add them to the product of the second two, and add that to the product of the last two. So 0 times 8 is 0, plus 0 times negative 2 is also 0, and 4 times 2 is 8. So 8 and 0 plus 0 plus 8 is equal to 8. And the formula is the magnitude of this. And the magnitude of 8 is just 8. So the volume is 8 cubic units. Alright, this is question 4, and it's asking us to find the equation of a plane passing through a point, and that contains the line of intersection of the planes given, x plus y minus z equals 2, and 2x minus y plus 3z equals 1. So what I'm going to do is I'm going to try to find where they intersect. So I'm going to set z equal to 0. In doing so, we're going to have x plus y equals 2, and 2x minus y equals 1. And we can then write that y equals 2 minus x, Then we can plug it into this equation to have 2x minus 2 minus x equals 1. So that's 2x minus 2 plus x is equal to 1. Combining like terms, 3x minus 2 equals 1. 3x equals 3. X equals 1. And if x is 1, then y also has to be 1. So we have 1, 1, 0. Now, I'm going to say R1 is equal to this and the point given. So we're going to have 1, 0, 1, negative 1, 1. So it's going to be 1 minus 1, which is 0, negative 1 minus 1, which is negative 2, and 1 minus 0, which is 1. So now we're going to find another vector that's either parallel to or on the plane. To do that, we're going to assign n1 and n2. n1 is going to be the first equation, which is 1, 1, negative 1. n2 is going to be the second, which is 2, negative 1, and 3. And now R2 is going to be the cross product of these two vectors. So we're going to have I, J, K, 1, 1, negative 1, and 2, negative 1, 3. One times 3 is 3. Negative 1 times negative 1 is 1. 3 minus 1. For J, it's 1 times 3, which is 3, minus 2 times negative 1, which is negative 2. 3 minus negative 2. For K, it's 1 times negative 1, which is negative 1, minus 2 times 1, which is 2. So this is equal to 2i minus 5j minus 3k. And now we're going to take the cross product of R1 with R2. And that's going to be as follows. 0, negative 2, 1, 2, negative 5, negative 3. It's going to be negative 2 times negative 3, which is positive 6, minus negative 5 times 1, which is negative 5. This one's going to be 0 times negative 3, which is 0, minus 2 times 1, which is 2. This is going to be 0 times negative 5, which is 0, minus negative 2 times 2, which is negative 4. So then we can rewrite this as 11i plus 2j plus 4k. So we can now plug into the formula. 11 times x minus the 1 from the original plane passing through this, minus 1 plus 2 times y minus negative 1 plus 4 times z minus 1. And that's going to be equal to 0. So distributing, we have 11x minus 11 plus 2y, and this is a positive 1, plus 2 plus 4z minus 4 equals 0. This can be rewritten as 11x plus 2y plus 4z, and negative 11 plus 2 is negative 9 minus 4 is negative 13 is equal to 0. So then the answer is 11x plus 2y plus 4z is equal to 13.